On Monday class, we conclude chapter 12 with a last two problem set. As you can see here, homework 12.14 and homework 12.32. Homework 12.14 focuses on sketching a body plot, where problem 12.32 focuses on writing a function based on the body plot. These two problems will be very useful for you to exercise more, and I'm certain that this two problem will be slightly a little bit different than our previous problem. So this is a typical problem set that only is written in the J omega for all the transfer functions. So like what we usually do is replace J omega equal to S for all, and obviously by inspection you can see that this function only have poles but without the zeros. So let's start organize this equation a little bit by writing H S equal to 100 and then divided by S squared times S, actually 2S plus 1, and this seems to me that it is a low-pass filter because we don't have zeros here. So what we're going to do next is to put this in a proper form so that we can find out the frequency point for each. So HS 100, again we don't have the zeros, and then you have S squared times the S divided by 0.5, because that 2 inverse will be 0.5. So 0.5 is actually 1 over 2, and you have that as a 0.5 as the frequency breakpoint plus 1. So 0, obviously we don't have anything on that, and then you have the poles. We start at 0 and then 0.5. So to sketch each of the plot, I'm going to do the first thing for the 0. So it's actually going down with the negative 40, because you have S to the power of 2, negative 40 dB per decade, and the second one would be starting at 0.05 breakpoint. That because this is to the power of 1, so the negative slope actually is a minus 20 dB per decade. So my hint to you is that to actually combine both together, you need to plot the first one, minus 40 dB per decade, and then the second one is again with the minus 20 dB per decade. So the solution to that is actually you will have to combine the both in order to get to a single figures. So the next question will be the other way around, when we are given a body plot and then to write a transfer function. So you can see that the breakpoint is 4, 2, 10, 100, and then 600 as the breaking point, and you have to look carefully about this, the slope, whether or not it is positive or negative. That will determine the zeros and the pole, and then the higher value than 20 dB per decade indicate that you probably have to the power of 2 or more for each polynomial. So the 40 is actually is continue after that second section, 100. That means that you have a power of 2 at least. So you will have to have 4, 20, 100, and 600 as the breaking point. But the 10 here actually imply that you will have to know where is the starting point of that function, because obviously this is not starting at 0, so you will have a constant value in the beginning of the transfer function. That's the hint that is given to you. 10 with a 20 dB per decade, so you have a 0 dB for the transfer function, and then you will use this to find out the constant for the transfer function.
I should mention that in order to find the value of the constant, for example, for the last questions, we should substitute a value in there to find out the decimal amount first. So let's see if you will have to include omega equal to 1 omega 1 radian per second. That means if you will have to substitute that into the H formula, which I can repeat that here, Hs is equal to K J S plus 20, and then the S plus 4 S plus 100 multiplied by S plus 600 to the square, because we have the slope, remember, minus 40 dB decibel per decade. So once you have this, substitute this value of 1 radian per second into that equation, you will get something like Hs is equal to magnitude equal to minus 20 decibel. That's equal to 0.1, and when you have that 0.1, eventually substitute into that, then you have a 0.1 equal to K, and when you have this amount of then you have to pull all constant out, because remember you have to put it in the form of S over 20 plus 1, something like that, to this equation. So the K will be, when you extract that constant out, will be multiplied by 1, and then here you have 20 divided by the denominator value with 4 times 100, and then multiply by the 600 squared. So eventually, when you have this number in place, then what you need to do is to evaluate the K here. So the K will be something that you have to find out later.